In this module, I'll be covering drive cycles, what they are and how they work. A drive cycle is based on distance travelled versus time and incorporates such aspects as engine speed, engine load and engine temperature. Certain parameters need to be met before modules can monitor and carry out self-checks on systems and components to meet ever-growing emission standards. This is why vehicles have readiness monitors. They can be viewed on scan tools for emission purposes. They can be found in the OBD2 section of your scan tool. Here's a list of some readiness monitors that you may encounter. These include component monitoring, misfire monitoring, fuel system monitoring, and catalytic converter monitoring. Some readiness monitors will be associated with the engine warning light. Some vehicles don't use readiness monitors, but use a combination of lights on the instrument cluster for the same purpose. For example, a flashing engine and cruise control light to indicate an emission fault. Not all drive cycles are related to readiness monitors. For example, diesel particulate filter regeneration has a specific drive cycle, but does not have a readiness monitor. Instead, these systems will indicate by either a flashing or steady light on the instrument cluster. For a readiness monitor to complete, different parameters must be met. Each different drive cycle is designed to meet a specific set of parameters for a specific type of fault. Bear in mind that there is not one drive cycle that covers all faults. The appropriate drive cycle must be selected for the fault you are dealing with. There are two types of readiness monitors, continuous and non-continuous. Some examples of continuous monitors are misfire monitors, component monitors, and fuel system monitors. These systems are continuously monitored, some with just the ignition on and others with the engine running. For most continuous monitors, a specific drive cycle is not necessary. Non-continuous monitors require certain parameters to be met before the module can determine if the fault exists. This is where drive cycles become important. Clearing the codes and a quick trip around the block will not allow the readiness monitors to complete, giving you a false indication that the fault has been repaired. A catalyst efficiency monitor is a perfect example. The ECM makes fine adjustments to the injector pulse width under certain driver conditions to see if the downstream sensor reacts. This is done to see if the catalytic converter is functioning correctly. For this monitor to complete, the engine needs to be at operating temperature, driven at a specific speed and load for a given period of time. Failure to perform the correct drive cycle will mean that any code you have cleared will not reset. Next thing you know, the customer is back with the same issue. Another example is the EVAP system. The module will monitor the canister purge under specific driving conditions, and these conditions will be very different from those for catalyst efficiency. Some non-continuous drive cycles can take up to 30 minutes to complete. Follow the instructions, there are no shortcuts. Thanks, David. Let's go through a typical process of a catalyst efficiency drive cycle. Before you carry out a drive cycle, be sure to find a long stretch of road with minimal traffic. We start with the engine idling for 3 minutes at operating temperature. This ensures the system is in closed loop. I now accelerate to 80 km per hour or 50 miles per hour with a steady throttle and the air conditioning off. This is maintained for approximately 60 seconds, so the system can stabilise under a constant throttle and a constant load. This is where the module will compare the oxygen sensor readings. During this phase, the ECM initiates small amounts of fuel to be added into the combustion chamber, causing a rich mixture. The response from the downstream sensor will determine its efficiency. Once this is achieved, the driver backs completely off the throttle and rolls to a stop without touching the brake. During this time, the system enters injector shut-off mode. If these parameters are not met or interrupted, the monitor will not complete. It's a good idea to do a couple of these drive cycles. Now that we're done, let's go back to the workshop. Let's take a look at the two drive cycles that I performed. From the captured data, we can see that the first drive cycle readiness monitor did not complete. This is because of heavy traffic I encountered. The second attempt shows a completed readiness monitor. If several unsuccessful drive cycle attempts are made, the engine light will come back on. Remember, always follow the manufacturer's specifications when performing drive cycles. That's the fundamentals of drive cycles. We've looked at various ways systems and components are monitored. Understanding what a drive cycle is will give you a huge advantage when dealing with intermittent faults.